Okay, so now let's move on to a period change. So solve for theta between 0 and 2 pi and the general solution. So let's take the equation, sine theta, sine 2 theta is equal to 1/2. Well, in the next chapter, we're going to get into a lot more about the period change and what happens to the graph. But if you are looking at the notes and you can see down below, you can see the graph get horizontally compressed into 2 full cycles between 0 and 2 pi. So we're going to be looking at both of those graphs down below. So the first thing that I want to do is, this looks weird to me. So I'm going to make m, I'm going to do this off to the right, m equals 2 theta. So now I'm going to substitute m in for 2 theta. So sine m equals 1/2. Now this should look much more familiar. Well, we've done this question previously in grade 11 and now in grade 12 in the previous 2 sections ago video or so. So sine theta is equal to 1/2. Well, I'm going to draw an ASTC graph. And I'm going to put 2 triangles where sine is positive. And I don't really mind how big they are. And I know sine theta by definition is equal to opposite over hypotenuse. I know we've spoken about the new definition of sine is the y value of unit circle, but we're going to keep opposite over hypotenuse as well. So I can label the triangle with opposites of 1 and hypotenuses of 2. And I know from my special triangle, I'm going to draw one of these special triangles off to the right in the same orientation. I'm going to label it 1 and 2. And I know the other side is root 3. And I know that opposite of the 1 is the angle pi over 6, or 30 degrees opens up to the 1. And I'm not even going to put the other angle because it's unnecessary. So I'm going to put that angle as both of my reference angles, pi over 6 and again pi over 6. And then I'm going to put my arrows in, and I'm going to put them in red. So I'm going to put my arrow from my principal axis to the terminal arm, and then again another one from my principal axis to the terminal arm. And then I'm going to answer the question. Well, I know that my first arrow is m, because I'm working with m now. We substituted in the top right, we substituted m in for 2 theta. Our new equation that we're working on is sine m equals 1/2. We're going to work through that and then substitute back in later. So m equals the arrows. The first arrow is pi over 6. And some people like to use commas. I don't. I would prefer you not, because it gets messy. We want 2 nice clear columns of where we're working with. So now m is then equal to, well, I'm going to mark 0 and I'm going to mark pi, and I'm going to change pi to be a denominator that I'm working with. And then I know that I'm just pi over 6 short of 6 pi over 6. So I'm just 5 pi over 6, and we worked with adding and subtracting radian measure earlier, so 5 pi over 6. And then in the notes I've checked my answer and I make sure that sine of those things are both 1/2. But m is these things, and the original question at the top was sine 2 theta is equal to 1/2. So off to the right in big red, I made m equal to 2 theta. So now back to where we're working down below, I need to substitute 2 theta back in for m. And this would have been very messy if I used commas, because I want 2 nice clear equations side by side. And then I have to solve for theta in both cases. So I can divide both sides by 2. Remember, we're not doing that, showing them anymore. If I divide both sides by 2 or cross multiply, the answer is pi over 12. And I'm going to circle that answer that is going towards. And then again, pi theta equals 5 pi over 12 again. If you have difficulty cross multiplying, get some help with that. So I know that I drew the graphs down below, but I'm going to draw them off to the right. So I'm going to draw a graph of sine. Now, you guys haven't seen this graph before much. Plug it into your graphing calculator. Excuse me, I'm going to do it in proper order. we have a point here and at the end and in between and there and there. And it's a very nice little pattern. So this is seen on our formula or review sheets if you've checked those out already. But it's just this little sine graph. It's a little wave happening in the world all around us. And that is its shape. And that's the graph of sine theta. Y equals whichever. Now, if I want to graph sine of 2 theta, well, that's a horizontal compression. So where I used to have my last point is now halfway. So everything is halfway. And that is shrunken, but I'm still going from 0 to 2 pi. I'm going to write at the top of the page a little bit about the question. 0 theta between 0 and 2 pi. Big red. That means between 0 and 360 degrees, or in radians, 0 to 360, 0 to 2 pi. So that means I have to go all the way and do a full cycle. So I have to do another, excuse me, I'm going to do that properly. Gosh. So 1 at the beginning, 1 at the end, halfway in between at the max, halfway in between at the min. We start to get this nice little wave pattern. We basically want to memorize that shape. And this is the graph of 2 theta, actually keeps going. So now I'm going to be in red in the graph that we just drew above. So when's that equal to a half? Well, I know that sine only goes up to 1 and down to -1. So when's it equal to a half? Well, it's equal to a half, y equals a half, at this location and that location, which turns out to be our m values. Our m values, this one is here, and this one is here. But we're working with theta, so we have to use our graph down below. So if I know that sine goes up to 1 and down to -1, well, when is it equal to 1/2? Well, here, the same place it was equal to a half last time. So I can draw on the line y equals 1/2. So back up to the top in big blue, if we're going from 0 to 2 pi, that means that we've only answered 2 of our questions. Down back to the graph below, we've only found this point and that point, which is this point and that point respectively. But we need to find the other points. So we need to find the period. Now, the period has a formula. P equals 2 pi over b. Now, I'm running into video down below, so I'm going to do this really quickly. My b value in the form sine b theta from above is a b value of 2. So if I substitute 2 in for b, then I can cross the 2 off from the top and the bottom, and I simply have a period of pi. So I need to take both of my answers and add pi to them. So if I take pi over 12 and add pi to it, well, that's adding 12 pi over to it. So that's 13 pi over 2. And then if I add pi to it again, that's adding another 12 pi, over 12. I'm adding another 12 pi over 12, which would equal, I'm going to use a comma this time, 25 pi over 12. Now, again, big red at the top, I'm going to overline blue. It said 0 to 2 pi. So down back below, I'm going to cross out that solution that's greater than 2 pi. But I need to take my other theta, 5 pi over 12, and I need to add pi, the period that we calculated off to the right again. We're simply adding the period over and over again until we're outside of the domain given above. Read all those English sentences written in the notes. So it would be 5 pi over 12. Whoops, excuse me. So it would be 5 pi over 12, 5 pi over 12 plus 12 pi over 12 would be 17 pi over 12. And I'm not going to add it again. I know it's outside. I don't need to reject it. So now I have those 4 answers. So those are my answers between 0 and 2 pi. But they also want something called the general solution. I'm going to shrink this up a little bit. So the general solution, remember, theta equals the first angle we got, pi excuse me, I'm going to write out the actual general form for the first time. So for the second time, it's in the formula sheets, remember. Theta gen equals theta STP plus Pn, comma, NEI. Now that is the formula. We need to remember that formula. So when I want to do the general solution for my answers above, well, I take my first and smallest answer, and I say theta gen equals, you don't really have to include the gen. If they ask you for the general solution and you give them the correct right-hand side, they're probably going to give it correct. So my first theta in standard position from the arrow in red I just drew is pi over 12. I'm going to make that look like a better 12. And then plus p. Now what was p? Well, I just figured out my period earlier by writing the formula p equals 2 pi over b, having a b value in the general equation, sine b theta, dividing by 2 and simply getting pi. So I say pi n, comma, NEI. And then again, I can give my other one, theta gen equals my other, I'm going to draw an arrow from above, my other answer, 5 pi over 12. My other smallest answer, 5 pi over 12. Plus pi n, comma, NEI. And those are my general solutions. So I'm just going to slide those up a bit in case those ran off the bottom. So again, theta gen is the two smallest angles in standard position plus Pn. We're going to get a lot more into general solutions a little bit later and how sometimes they cover each other. So I'm going to put a big, huge red box around that answer. So again, remember, if they ask for answers like 0 to 2 pi, we give them these answers above, these 4, 1, 2, 3, 4. And if they ask for the general solution, we give them the answers down below, like these two answers, possibly different, possibly one general solution. So if they ask us for both, we give them both, but just make sure if they only ask you for the general solution, don't start giving them the answers above. Period change is difficult. We're going to do a lot more period change in the next chapter and the following one. Lots of the times, different schools, public schools do it in a different order, private schools or different schools, online schools do it in a different order, so beware of which order they do it and how I do my order of notes and whatnot. Usually a good idea to watch videos on all of the topics and then kind of go back and forth, but you are very limited on time, so good luck to you. Period. Period is going to be one of the most difficult things that we find. It incorporates transformations, horizontal and vertical compressions, etc. And yeah, next chapter. Period change. Beware. P is equal to 2 pi over b for cosine sine. P is equal to pi over b for tan. Be aware. Check your formula sheets. Write your formulas down. Highlight them. Memorize them. Okay, let's take a look at some algebra, some period, equations, etc. So let's start at the top with 2 sine x, remember interchangeable with theta, plus 1 equals 0. So I can subtract 1 from both sides. 2 sine x equals -1, and then I can divide both sides by 2. Notice I do perfect graph paper work. The top is the top, the bottom is the bottom. I would never write halfway. Then I learn a lot more about my cross multiplication and whatnot. When I divide both sides by 2, the 2 just comes down to the other side. Looks a lot clearer. So an example off to the right, 5 minus 3 cosine theta x, equals 4. Well, let's manipulate this thing. So let's subtract 5 from both sides. -3 cos x equals -1. And then if I divide both sides by -3 cosine x equals 1 over 3. Now you may be asking, is that it? You never solve for x. Well, I'm going to do what I'm going to do a lot of the time in the future now. Dot, dot, dot. Dot, dot, dot. We've seen this in the past. We've seen this Sine theta equals negative a half. We've seen in the notes. We've seen cos theta equals 1/3. The one on the left we'd solve with special triangles. The one on the right we'd solve with the inverse calculation. I'm going to shrink in these up a little bit. So let's take a look at a couple interesting other ones. Well, one interesting other one for the moment. Sine x equals x minus 1. Now this is very interesting. The notes goes into a little bit further as to how to exactly graph it, but usually this will be a multiple choice question, and look down and see that the decimals are not 3.14 or 1.57 pi divided by 2 or the whatever 4.5 something, whatever 3 pi over 2 is. And if it's not one of those, then you're probably good, or I mean, you actually have to go through like pi over 6 and pi over 3 and all that, but either way, lots of times it helps to graph it. So we say y1 equals the left-hand side, and we say y2 equals the right-hand side as seen in your notes, and you graph it and find the intersection, and then notice there was no y involved, but the x value of the intersection will be the point on that graph. So x equals 1.93 from the graph. I'm just going to draw a little one. Sine x, x minus 1, and then we have that with an intersection right there. Put it in your graphing calculator, find that intersection. Sometimes you just need a calculator. Okay, so going down the page, let's say cosine of pi over 2x is equal to 0. Cosine of pi over 2x is equal to 0. Well, the funny looking thing here, I'm going to make that 0 better. The funny looking thing here is this. So off to the right, I'm going to make m that. Then I'm going to substitute m in for pi over 2x. Therefore, cosine m equals 0. And notice I just write m equals. Some teachers will actually take off the half mark for not saying let m equals. So we should say let m equal. I haven't been doing it in the past. I'm not going to do it in the future. So cosine m is equal to 0. Well, we've explained that in the previous section. Cosine, by definition, let's write it off to the right. You know what? I'm going to write it below this time. Cosine theta is equal to x. And I'm going to put a box around the definition so I don't get confused with above, which means that I am looking for an x value equal to 0, and I need to know what theta is equal to. Well, where on the unit circle do we have an x value of 0? Well, that, because we're working with m, our answers are m equals the angle where x is 0 is up and down, which means that m is equal to pi over 2 and 3 pi over 2. Notice no commas, two equations side by side. But I made m this, so I need to put that back in for m. So I have to substitute pi over 2 x in for m into both of the equations that I created above. And notice that's why we don't use commas, so we always have nice equations side by side. So then I need to solve these. Well, I can divide both sides by pi, and this one I can times both sides by 2. I hope you like that simplicity. And therefore, x is simply equal to 1. And now I can times both sides by 2, and I can divide both sides by pi, and therefore x is equal to 3. Now, let's just assume, I'm just going to draw a value of a domain that we usually use. 0 is less than or equal to x from the original, less than 2 pi. A nice simple domain. Well, we know that 2 pi is 6.28. So I need to find the period again. I'm just going to do that right above. So my period, if I remember, the formula is sine b theta, so it's cos b theta. I need that b value because p is equal to 2 pi divided by b. And my b value is that, so I'm going to cross this thing off and put it down below. And for anyone who is advanced in math, feel free to watch these steps. Outside of that, go back and work on your fractions. Take a look at the cheat sheets at the beginning. They have some fraction work that we have to be very familiar with. But I'm dividing fractions so I can flip and multiply. And then, after I've done that, excuse me, x is not part of b. Take the x out of that. X is not part of b. Excuse me. So then I can cross off my pi from the top and the bottom, and then I can get a period equal to 4. So then, remember from the last question, we want to take both of our answers and we want to start adding the period until we get above the domain given off to the right, 0 to 2 pi, or 6.28. So if I take my first answer, x equals 1, and I add the period of 4 to it, 1 plus 4 is 5. And if I add it again, I'm outside. And if I take x and I add the period, x equals 3, and I add the period 4, I get 7. But that is outside of the domain that we spoke about off to the right. So, definitely period is huge. It's very difficult. It's very easy to forget to add the period as many times as they've told you to be inside of the domain. In the notes, the question off to the right, tan theta. Well, that question, I'm going to make m the theta, then tan m is equal to negative 0.2. It says ... below that. Try and work through that solution and see if you can get to the correct answer. You know what? Let's work it out. Okay, I said I wasn't going to, but let's do this. So, tan x minus 1 is equal to negative 0.2. So I know that I'm going to make m equal to x minus 1, and I'm going to put a box around that to remember to bring it back in later. And I'm going to say tan of m equals negative 0.2. And as you can see, there's a little ... below there, which means that you should be able to do this work. It would be an ASTC graph with two triangles where tan was negative, with an opposite of 2 maybe, and a hypotenuse of 10, or 1 over 5, anything that gives you 0.2. Then we would do the inverse calculation, second tan, and get the reference angle. And then we would put our arrows in and figure out what our arrows are. Then we would use P equals pi over B for tan. Then we would figure out what the period is. Then we would start to add the period, as you can see in the notes, until we're outside of the domain. So let's take a look at a much more difficult one. Sine pi over 4 x minus 6, be good with your brackets, equals 1 over 2. Well, we're always going to make m the funny looking thing as we did before. So now off to the right, we're going to make m equal to pi over 4, open bracket, x minus 6. And then we're going to simplify it to be sine m equals 1/2. You guessed it. dot, dot, dot. We've seen that before. We know what m is equal to. We've done this many times before. ASTC graph, two triangles where sine's positive. Opposite of 1, hypotenuse of 2. Reference angle of pi over 6. Angles in standard position, draw on your arrows, and we get arrows where m is equal to pi over 6 and m is equal to 2 pi. Excuse me, 5 pi over 6. Then feel free to look in the notes. I have taken what I made for m and I've put it back in for m in both locations. Then I have solved for x, doing algebra from grade 8 and 9. Then I figured out what the period was by p equals 2 pi over b, with a b value of pi over 4 to get a period of 8. And I added and subtracted the period until I was outside of the domain 0 to 2 pi. It's implied if they don't give it to you. So these questions are now dot, dot, dot.